Hello and welcome. Thank you for the nice introduction. As mentioned, my name is Ryan Slater from Innervink and I'm the Business Development Manager responsible for plastics and advanced materials. Today I'm going to speak about additive manufacturing. But firstly, a little bit about Innovync, who we are and what we do. So Innovync is a manufacturing machinery and solutions provider operating in the stone, glass, plastics and advanced materials sectors. We like to work together with our customers to not only provide off-the-shelf machines, but customised solutions. One of the companies that we represent is Italian machinery brand Cms, and Cms is part of the SCM group. Across the group's range of companies and machines, there are very few materials that we're unable to process, including wood, stone, glass, plastics and advanced materials. CMS provide a variety of machinery solutions including small and large format multi-axis CNC equipment, thermoforming machines, beam saws, materials handling and water jets. Included in this range of machinery are numerous machines developed specifically for the advanced materials or composite sectors. CMS have a strong history of partnering with market leaders, particularly in the marine, aerospace and automotive sectors, the likes of Boeing, Lockheed Martin, Oracle Team USA, Artemis Racing, Alfa Romeo, Pininfarina, to name a few. Some of the CMS customer references can be seen here. We also partner with various other European suppliers for materials handling, production lines, robotics and presses, including idle press for small and large format hot and cold composite presses, including resin transfer moulding and reactive injection moulding. Now to our topic, advancement in hybrid additive manufacturing processes. You may ask yourself, why does a CNC machinery supplier become involved in additive manufacturing? CMS is an acronym for Customised Machine Solutions. It's in their DNA to provide customers not just with the solutions that CMS have, but the solutions that customers actually want and need. So when CMS customers requested ways to innovate composite layout processes and shorten the supply chain, specifically for automotive composite parts, CMS partnered with the Fraunhofer Institute in Germany, who specialise in R&D of machine tools and technologies for forming plastics, and started the journey of hybrid additive manufacturing. More on this later. Additive manufacturing or 3D printing is a very young industry with high growth that is attractive to many sectors with considerable advantages. It's also considered a greener way of manufacturing due to the related material and energy savings created by this kind of production. Large format additive manufacturing, in our case with the Creator, is obtained by screw extrusion combined with milling and is performed by the machine seen in the next slide. Additive manufacturing or 3D printing has only been around since approximately 1984 and large format additive manufacturing since about 2014. Up until 2009, AM was mainly used for prototyping, but since 2010 has also been used in the production of finished parts, production equipment and tooling and jigs, and has generated very strong growth in a short space of time. LFAM has generated particular interest in the aerospace, automotive and industrial machinery sectors. Between 2009 and 2019, 61% of additive manufacturing's growth has been related to tooling. LFAM increases competitiveness of composite parts manufacturing due to the material, energy and processing time savings achieved by this form of production. The Creator is a classic format 5-axis machining centre coupled with an interchangeable screw extruder, and here you can see a short little video of our machine in action. Its various applications include machining jigs, lamination masters, direct mould manufacture, and can replace the use of epoxy tooling board or be a substitute for FDM. Some of the key benefits of LFAM are the high flexibility, the integration of a large format 3D printer with milling capabilities. You're able to print different types of materials in different ways and also process and trim the finished composite parts within the same cell. Material savings. Using this form of additive manufacturing, it is possible to save over 5 times the amount of material required by other tooling or AM methods. It's a sustainable solution. Fewer subparts can be achieved, reducing the manufacturing time and lowering the cost when compared with traditional tooling or FDM methods. A good example is a case study from a customer, a high accuracy support made from an aluminium base and 3 subparts used for the reference surfaces and manufactured by a standard FDM printer were replaced with 3 parts in total printed by the creator. The 4 parts manufactured in the typical method required 26 hours of printing, whereas the creator, they took only 2 hours of 3D printing and 3 hours of milling. Also, in the context of epoxy or similar tooling board replacement, we've seen a raw material cost saving higher than a factor of 5 due to the hollow nature of the 3D printed parts. Our approach is less material, more printing speed. And we can confidently say that the creator uses up to 5 times less raw material than competitors to print the same parts. Very large formats. Due to the large mechanical base of the CMS machinery range and the interchangeable extruder via automatic tool changer, very large working envelopes are achievable. CMS currently offer working envelopes from 3.6 by 1.8 metres up to 4.8 by 2.6 metres in X and Y and 800 millimetres in Z. Larger formats are being developed at the moment. The current screw extruder is capable of printing up to 10 kilos of material an hour, with development already in progress for extruders capable of printing 20 and 100 kilos an hour, which would then make the option of applying this technology to the larger format range of CMS machines suitable. The partnership with the Fraunhofer Institute is focused mainly on the screw extruder, with continual testing around the quality of the extrusion, the absence of voids in the print, and the vacuum integrity of the finished parts. The initial R&D was done using a polyamide reinforced with glass or carbon non-continuous fibres. CMS has since tested many other thermoplastic materials, and the materials used are similar to commercial thermoplastics used for injection moulding or extrusions. And they include PP, PESU, PET, PEI, ABS and Airtech Deltrum. The priority is if a material works well for a specific application, CMS will research and test the material, and they're also open to testing new materials in their CMS Creator Lab. The extruder uses a common HSK tool connection and it has a patent pending for the automatic connection, which allows the machine to interchange between extruder and milling tool without any human intervention. The extrusion is via a single screw extruder. The melting of the material is performed and controlled inside the extruder using friction. The melted polymer exiting the extruder is deposited in layers that plasticise and form a single part. The creator allows for 0, 45 and 90 degree printing, which is useful for when different material direction is required to achieve greater strength in the printed parts. One application where CMS sees Creator being particularly suitable is the manufacture of carbon fibre reinforced polymer tooling for autoclave cured parts. Typically, to build this kind of tooling, a master plug first needs to be produced, upon which subsequent tools are moulded. With the Creator, a core tool part is printed directly and can be laminated and placed directly in the autoclave, eliminating the need for a master plug. The Creator system is designed to quickly build composite jigs, fixtures and tools that are lighter weight than their aluminium counterparts. For example, a carbon fibre PA6 jig can be built in just over 3 hours using Creator and weigh just 14.6 kilos, compared to the traditional aluminium version, which can take up to 8 days to manufacture and weigh 114 kilos. The key for Creator is to control the shrinkage and warpage and maintain good adhesion between the printed layers and control the cooling. Together with the Fraunhofer Institute, CMS is developing additional capabilities for the next generation models, such as larger print head, which I've previously mentioned, geared towards the marine and aerospace sectors, and a machine that includes 2 heads for simultaneous printing and milling. Now on to some, what I can show you of some real world applications. In June 2021, the first commercial project developed with the CMS Creator was announced in partnership with Italian fabricator Bacella. The initial conversations between CMS and Bacella started approximately 5 years ago, and these conversations resulted in Bacella partnering with CMS during the development of the Creator, with Bacella contributing knowledge and experience in industrial applications. The goal was to print composite components such as tooling and jigs and then immediately finish the parts within the same machining centre, saving both time and labour required to move the parts from one machine to another. The first project CMS and Bacella undertook was called Resto Mod Maserati, a challenge launched by Tommaso Trussardi for the Motor Valley Festival in Italy. Restoring a Maserati 3200 GT, for which Bacella was tasked with delivering 26 re-engineered carbon fibre body components, including the doors, roof, bonnet, front and rear bumpers, reimagining them with a wider and more modern designs. Each component was built from a carbon fibre preg, manufactured via hand layup on a 3D printed mould, then cured via autoclave. Using the CMS Creator, 20 individual moulds were printed using a 40% carbon fibre filled PA6. Using the Creator process enabled close to zero waste manufacturing of custom moulds and also saves time and money during the production because 3D printing and milling occur within the same cell. The ultimate goal for the partnership was to use 3D printed moulds to produce an entire carbon fibre restoration vehicle. Another project here was for Mitsubishi for the Dakar Classic race, where the CMS Creator was used to create moulds for the front and rear bumpers and also the fenders of the vehicles. One of the CMS's customers, MDC Design, who are a major supplier of tooling, jigs and moulds for the automotive powerhouses, the likes of FCA, Stellantis, Lamborghini and Ferrari. These customers are continually asking to reduce both the weight and cost of the products supplied by MDC. And using the Creator, MDC is able to significantly reduce both while still maintaining a high level of accuracy required and expected by these customers. Christian Pentavolpe, one of the founding partners of MDC Design, says the main benefits I see of this type of manufacturing is the weight reduction and the lower cost of manufacturing compared to traditional methods. In the past, construction and additive and accuracy were two different things that were not in parallel. Now, however, we've reached a point of precision printing and fitting. Another recent installation of the Creator was at United Aerospace in the UK. United Aerospace, amongst other things, have many UAV contracts and have seen them work closely with their clients, assisting them in the constant evolution of their products while continuing in full-scale production. The CMS Creator was the next logical step in the company's growth, with numerous benefits that have improved efficiency and reduced manufacturing costs, while maintaining quality and accuracy, particularly for the active UAV contracts. Here you can see some future developments of the Creator, using the existing open frame design of some of our larger 5-axis machinery, typically used in the marine and aerospace sectors, with machine lengths commonly in excess of 30 metres. We can also see here and here the dual head application, where we can flexibly configure the machine to have an extruder head and print head working simultaneously, or twin printer heads or twin milling heads. An application where CMS was able to use the Creator for their own in-house testing of another useful technology, the UHF table, universal holding fixture, which uses intelligently CNC-controlled vacuum cups to perfectly align to curved surfaces. The UHF tables are commonly used for machining aircraft skins. The suction cup calibration is crucial for this equipment, and the most effective way to calibrate is to use a 3-dimensional reference part. A shaped sheet of fiberglass with known dimensions is used to check and calibrate the position of each suction cup and simulate processing. For the manufacturing of the reference sheet, CMS decided to 3D print a mould and laminate the test piece in-house instead of the normal way of outsourcing this kind of work. Using the Creator, CMS were able to see real savings, including a material saving of 83.4%. The additional material costs alone, when using traditional tooling, board and subtractive methods, would have been 5 times what was required using AM and the Creator. You may have noticed as you've entered into the space here on the right-hand side there, your left, we have a sample. This is part of a direct mould made by the Creator, and it's a small section of a wing mould for a UAV. The total mould had a print time of 9 hours and a processing time of 25.5 hours. Compared with traditional methods, this mould saved 74% of the material normally required to print this mould. Summing up, the Creator opens a new world of manufacturing possibilities, delivering a highly flexible AM solution with the added ability to mill both the printed products and also the finished composite parts created from these printed products. Thank you all for your attention. I hope you've enjoyed my presentation. If anyone would like some further information about the Creator or anything else that we're involved in, we're around for the rest of the day. Otherwise, my contact details are there. Thank you very much.